Let's now consider an example of partial neutralization where we don't have equal amounts of hydrogen and hydroxide ions. So in this case, the moles of H plus will not equal the moles of OH minus. So as a result, we'll either have an acidic or basic solution. Just as in with most stoichiometry problems, our first step is going to be to write out the balanced chemical equation. So here we have 1 mole of NaOH, 1 mole of HCl, producing 1 mole of water and 1 mole of NaCl, a 1:1:1 ratio. Our second step is to determine the number of moles, or the amount, of the acid and the base. So I'm going to use my moles is equal to concentration times volume, and I get 5.0 times 10 to the negative 3 moles of the base and 5.5 times 10 to the negative 3 moles of the acid. Note that when determining the moles of the acid and the base, I'm using the initial concentrations rather than the combined volume. Now, although we know the moles of the acid and base, we need to specifically know the moles of the hydroxide and hydrogen ions, because they are the chemical species which are interacting here. The sodium and chlorides are just spectator ions. So our next step is to use the molar ratios to determine the number of moles of hydrogen ions produced by the acid and the number of moles of hydroxide ions produced by the base. Here I'm illustrating where this comes from, in that sodium hydroxide, when it dissociates in water, produces 1 sodium ion and 1 hydroxide ion. So in this case here, both for HCl and NaOH, the moles of hydrogen ions and the moles of hydroxide ions will be equal to the moles of the acid and moles of the base. If we have equal moles of acid and base, we will have complete neutralization. However, in this case, we can see that we have more moles of the acid than we have of the base, or more specifically, the moles of H plus are greater than the moles of OH minus. So we can predict right now that this solution is going to be acidic. So we are going to be more specific and determine the exact concentration of excess hydrogen ions or hydroxide ions. So my first step here will be to subtract the number of hydroxide ions from the number of hydrogen ions, and that will determine the excess amount. So in this case here, we have 5.0 times 10 to the negative 4 moles of hydrogen ions left over after the reaction. Since we've now combined two volumes, in order to determine the concentration of hydrogen ions, we'll use the combined volume of the solution and use our concentration is equal to moles divided by volume, or the excess amount of hydrogen ions divided by the combined volume, to determine our new concentration. From here, if we wanted to determine the pH of the solution, we would just use our pH equation, in that pH is equal to the negative log of the hydrogen ion concentration. However, in this question, we're just asked for the concentration of hydrogen ions and hydroxide ions. Remember that once we know the concentration of hydrogen ions, we can always determine the concentration of hydroxide ions using the Kw equation, or Kw is equal to the concentration of hydrogen ions multiplied by the concentration of hydroxide ions. So by rearranging this equation, we get that the concentration of hydroxide ions is equal to the Kw value divided by the concentration of hydrogen ions. And we'll assume, unless we're told otherwise, that the Kw value is at SATP, so it's 1 times 10 to the negative 14, and we'll get our value for hydroxide ions.